Welcome to Space Startup News Live. I do this every week. It's a live stream where I recap my videos I've done over the last week. So that's usually 3 videos I do. I do 2 pre-recorded videos. And I do space news as well. So 2 dedicated videos, usually on one company, and then I do space startup news. I go over comments left on the videos, answer chat messages, and I also usually cover any missed news that I didn't cover for whatever reason, and preview upcoming content. So that's the plan. I do this every week now, and it's great if you can join. If not, you can watch it afterwards or whatever. So let's get into the first video of this week, which I did, I think I released on Tuesday. I put myself in the corner here. So this is K2 Space, building satellites for a post-Starship economy. So most satellites are small. Some of them are the CubeSats, which are tiny little cubes. The thing is, with Starship, that can lift 100 tons in a single launch, or maybe 150 tons. And it should be flying frequently, 3 times a week. I think Elon has suggested it could fly 3 times a day. So potentially you're lifting hundreds and hundreds of tons into orbit every day. So there are no satellite companies until now that are really building satellites for the post-Starship world. If you look at the graphic that the company has on the website, it's mass will no longer be our constraint. Everyone's building satellites as if mass is the worst thing you can have, and you have to make your satellites very tiny, and therefore you have to use specialized components. You can't use off-the-shelf industrial components because they're too heavy. So that's why satellites are very, very expensive. Everything's boutique, customized components that are expensive, take have a long lead time, just so you can keep the mass down. But with post Starship, when the Starship and another rocket launchers that can launch a large mass into orbit, you don't have to worry about mass that much. You can launch 5-ton or even a 20-ton satellite, and it's not a problem because there's flights every day. So anyway, that's the business plan. Rather than costing $4,000 per kilo, it's $100 per kilo. And I think Elon's even mentioned $10 per kilo. But even if it's $100 a kilo, you don't have to worry about mass too much. So K2 are building large satellites. These satellites they're not like the CubeSat ones, which are this size. They're like 3 meters by 3 meters by, I don't know what the height is, but they are big. They are big satellites. So they have 2 classes. They have a mega class, and then they have a giga class. And I think there's a graphic here of what they look like. So the width and the height would be the width and the length would be 3 meters by 3 meters for mega class. How tall it is, I don't know, but it's and the gig class would be probably at least 5 meters by 5 meters. We don't actually have the dimensions for the larger one, but these are very big satellites. I think you get the point. And the mega class will weigh, I think, 4.5 tons. I think they say on the website, something like that. And the giga class would be something like 15 tons. And fully fueled, it would be something like 20 to 30 tons for one satellite. So the advantage of that, though, is you can have a whole range of sensors, or you could have some very large sensors. So aperture size is the key thing for like optical systems, imaging systems. The more light you take in, the sharper the image, which is, for an Earth observing satellite, that's what you want. You want a sharp image. So you want a bigger lens, which means the whole sensor is bigger. And the same for like radar or whatever, communications. So with this massive payload deck, like 3 meters by 3 meters, you can stack a lot of sensors, or very big sensors, and big power systems as well. I think they're building an in-house power system that's 20 kilowatts of power. And in the Giga class, it's 115 kilowatts of power on a satellite. So just huge amount of power, huge space, and they're built for Starship kind of vehicles. In fact, I have a graphic here. I just remove myself for the moment here. Can I just? Myself back here. For the Mega class satellite, all medium launch vehicles are fine. Falcon 9 is fine. Upcoming Neutron. The satellite is about 5 kilos, 5 tons. Sorry. So Falcon 9 is fine. Neutron's fine. For the Giga class satellite, you're going to need a heavy lift launch. You're going to need Starship or Blue Origin would be the two primary launchers for the larger satellites. The other two, Falcon 9 Heavy and ULA, even with boosters, the VC6's 6 gem boosters, would struggle to lift them. Vulcan could lift one, but because of the small size of the payload deck, only around about 5 meters, it would struggle for the Giga class, which we think is probably going to be around 5 meters by 5 meters, but it could be more. So it's going to be New Glenn and Starship would be the main launchers for Giga class. Mega class, any medium launch vehicle could launch them. So that's the those are the launchers who could potentially launch these kind of satellites. And if we look at the stats for the satellites, so they're building 2 classes. The first class will be Mega class, and the dimensions are 3 meters by 3 meters for the payload deck. So that's where you put all your sensors and so on. The mass is going to be at least 4.5 metric tons, and propulsion is a 20 kilowatt Krypton Hall effect thruster. So this is electric propulsion, very efficient but quite slow. But this is apparently 4 times more the thrust of similar systems because it has more power. So it's got delta V about 2,000 to 3,000 meters per second. And I think they quote they can go from low Earth orbit to medium Earth orbit in about 3 months, which is much faster than normal. So, and then the Giga class, the actual dimensions, not sure, but it's probably at least 5 meters by 5 meters. And the mass is more than 15 tons. And once fully fueled, it'll be 20 to 30 tons. The power system, not sure, but it's probably 40 to 60 kilowatts. And the amount of thrust is between 2 and 4.5 newtons, which is still low, but it's more than current satellites. And the delta V is huge, 4,000 to 6,000 meters per second. So very powerful system. And you can put a lot of sensors on there. And you'd need something like Starship or potentially New Glenn to lift a satellite of that class. So yeah, it's a very interesting company because they're doing what no one else is really doing, which is building these very large satellites, which no one else is doing, and they can do them cheaper than other companies because they're not having to shape the mass, constantly trying to find components that are very, very light. They can just use industrial components. One example is for the, if I get rid of myself again. Okay, so that is K2 Space. I thought that was interesting because they're doing what no other satellite company is doing. They're building large satellites with a lot of power on board, so you can do a lot of things. And it's built for something like Starship or something of that class, something that can lift a large amount of mass into orbit. I mean, that system should be coming, should be operational in 2-3 years. I don't know, 3-5 years, but soon. So K2 Space is the only company that will build satellites that can take advantage of the size and power of something like Starship. So I think, was there a few comments? Yes, we had a few comments. Bring that up here. Yeah. So Joe Gogent AJ2997 says, this is what people don't get about Starship. It isn't just exciting because it is SpaceX or the ship to take people to Mars. It is a rocket that is aiming to change what was thought possible to launch into space. Just how Falcon 9 changed how people saw reusable rockets. Hopefully, so will Starship change how we use rockets for commercial companies and future projects in space. I know this sounds like a bot comment, but I just wanted to express why the space industry has really been getting a lot more exciting in just these past 2 years. So it's not just about taking people to Mars. Starship unlocks a lot of new capabilities for space missions, scientific instruments, space exploration, and also just satellites in orbit. You can do a lot more. The satellites can do a lot more. They can have more power and bigger sensors. So yeah, it's exciting for that reason. And we have Only Medium Stake 9005 who said, giant satellites will be the way to go in the long term. The more mature the constellation market becomes, the more valuable orbits will be. So going big makes sense, not to mention advantages that come with bigger antennas. Just look at ASTS versus Starlink. And a reply from Blue Steel 8376 says, I believe you are correct. Starlink satellites have gotten bigger with each generation. Another thing I mentioned in the video is that they're thinking that MEO, that is medium Earth orbit, could be the new LEO, could be the new low Earth orbit. In other words, if you put your satellites higher, like 600 to 1500 kilometers, first of all, it's less crowded because LEO is getting crowded now, especially with the constellations. Thousands and thousands of satellites are going in that kind of orbit. So you've got collision risks. There's a lot of debris there. So if you go to medium Earth orbit, because your sensors are more powerful, you still get the same kind of imaging you'd get from low Earth orbit from higher orbit, because your aperture size increases on your sensors. So it's less crowded. And also the satellites have better radiation shielding, so they can handle the higher radiation you get in medium Earth orbit. And also they're more difficult to shoot down, which is important for US Space Force and so on, and defense satellites, because there are anti-satellite missiles available, but they're optimized for low Earth orbit. It's harder to hit a satellite when it's further away. It's harder to track it. It's harder to engage it. So medium Earth orbit has a lot of advantages, and the mega and giga satellites are built to handle the extra radiation. So that's kind of cool as well. So that is my first video I did this week, K2 Space, and then I did a video on lunar lava tubes, which I think I have the graphic here. If I bring it up, that is, I want to bring up this one here. Yeah, using lava tubes for habitats. So I did when I was researching my Lockheed Martin's vision for lunar architecture, I think I briefly mentioned lava tubes, but I did some research into them, and I thought, okay, I think I need to do a dedicated video on lava tubes. So this is the video I did this week, and I really delve into reasons why they make a lot of sense. First of all, I think I have some graphics. Yeah, let me bring up this here. This is one of the, this is what's called a skylight. It's basically where the roof of a lava tube has collapsed, and you can see that there's some kind of there's some kind of underground system here. You can see the debris on here. So we found NASA has found about 200 of these pits. They have an LRO satellite, Lunar Reconnaissance Orbiter, and it constantly goes over the moon and takes images. So now they've classified something like 200 pits, and we think there's the whole system of lava tubes under the moon, and these lava tubes can be very, very big. I think there's a graphic here. Yeah. So this graphic has the lava tubes on Earth, and then some of the lava tubes we found on the moon. So the ones on the Earth are generally not that big, right? At the depth is to 10 meters, 20 meters. Then when you look at some of the ones on the moon, this particular one in the Sea of Tranquility, so depth of 155 meters. Marius Hills, which is I think a lot of startups and space agencies want to investigate this particular one, Marius Hills. It's on the near side. It's got an average depth of 110 meters, and length could be 40 to 100 kilometers length. So you could put entire lunar city in here, no problem at all. So yeah, these lava tubes are absolutely huge in terms of like the diameter, the depth, and the length. So the advantage is you don't have to worry about solar flares, cosmic background radiation, which you would on the surface, because you've got a big roof, at least 10 meters, and some of them are like 70 meters down or something like that. So you won't get any radiation there. And the other big advantage is the temperature doesn't fluctuate that much. If you look at, there's various places on the Earth. You can see that a lunar lava tube at -20. It's cold, for sure it's cold, but it's not so cold that like there are places on Earth that are colder. North Pole is colder. Some places in Antarctica are much colder. So it's -20. So the heating the lava tube, if it's sealed, would not be such a big problem. And the power requirements to heat it are nothing like what would there be on the surface. I mean, the temperature on the surface be 120 degrees, it could be -170 degrees. So you've got massive issues of heating or cooling. So that's not the case with lava tubes. You're protected from the radiation. They already exist. They're huge in size, so they have a lot of advantages as opposed to being on the surface. So yeah, so that's the advantage of potentially using lunar lava tubes for habitation. And it's not as if you have to use lava tubes and not use the other systems. You can use hard shell habitation. You can use inflatables. You can use 3D printing, and you can do that within the lava tube as well. So you don't have to just seal it. You could just, as we had seen in this graphic here, you just put your habitat within the lava tube, and then basically you can level the ground. You could perhaps seal the sides and the roof, and then at some point, once you're doing you're processing the regolith of other reasons, you'd have the resources to pressurize the lava tube once it's sealed, and then perhaps add a dome over a skylight, and then you've got the view, and you've got a sealed area with air inside, and then you don't need to wear spacesuits and so on. So that's the idea of lava tubes. I think they're very interesting, and potentially that's where we could put bases or storage or something like that. So let's see what people are saying about lava tubes. Get rid of myself again for the moment. So Joe Gogint AJ2997 says, thanks for this video. It haven't really taken lunar lava tubes very seriously, but now I see why they are vital for the beginning stages of lunar colonization. Thanks again for showing that there are many companies that have innovative solutions for this. However, my favorites are the X-Arcs proposal and the ESA Lunar Leaper. Yeah, so in the video, I I include a few proposals from different space agencies and various companies, and about how to take advantage of lavitubes. So ESA has a Lunar Leaper. It's a little robot that can jump. So it can jump into a lunar lavitube, use the sensors, and basically map the area. One of the problems with lavitubes is the slope into it could be very steep and hazardous. So you've got to map the whole area first using robots. And thank you, Wayne. Thank you for joining. Good to see you. So yeah, just talking about lavitubes at the moment, and ESA has a Lunar Leaper. It's not a mission that's going to happen at the moment. It's just a proposal. NASA has some proposals as well, and various other space agencies. Japan has one. iSpace proposed some kind of a lunar lavitube exploration mission, and that was March 2025, so pretty recently. So yes, what else? We have Uncle Fester 84. Honestly, I cannot see Luna becoming a permanent habitation for a person, considering the low gravity. I'd be ready to bet that proper habitation would be on a rotating space station, while going to the surface would be only for work, like how saturation divers do today. So, I mean, I think you can put people into three groups. There's like people who think we should just explore space using robots, safer, cheaper, and the people like Carl Sagan and so on, who basically just send robots to all the planets and moons, and we'll do the science that way. So they're kind of very focused on the science, and robots is all we need. That's one group of people. And then you have another group of people who thinks like space is the destination. Once you are in space, you have arrived at your destination. You build orbiting space stations, and you can just live in space, and that's it. Occasionally, you may want to visit planets, but you live in space, and I think that's a very, very popular opinion. And then the third group of people is people who really like planets or surfaces. So they could go from one planet to another. They go from Earth to Mars, and you explore all the planets and moons and settle at all those places, but you're just going through space to somewhere else. And there's people who want to live in space. So I would categorize someone like Elon Musk as liking planets. So he wants to go to Earth, to Mars, and maybe other places, but the focus is on other planets and surfaces, other worlds. And then someone like Jeff Bezos, I think, is more, let's go to space, build orbiting space stations, and live in space. So those are three groups of people, I think. So, I mean, it's just people's different opinion on what the end goal is. So, yeah. So I just brought up that opinion because it's a very, very common opinion. And we have a comment from insert phrase here 15. So I clipped part of this comment. It's actually longer, but I have this section here, and he's saying, if I bring it full screen, while you can envision building on the surface by using some really strong insulation panels to protect the floor from freezing your habitats, and even digging into the regolith and insulating your habitats, these tunnels are going to be very cold, even if they are completely sealed off. Might be a decent place to build habitats, but then you don't have sunlight for solar panels near your habitats. So there's a trade-off. Ultimately, I think that the poles with ridges that are in continuous sunlight for solar are likely the best location, especially as there is some likelihood of finding water there. So that is the current plan. The current plan is for Artemis is a Artemis base camp that's going to be very near the South Pole, places where the sun is practically shining 80 to 90% of the time. So you have continuous power during the lunar day for 2 weeks. But the problem is at night you have no power at all. So I think the first mission by Artemis is 6.5 days. So it's going to be during the lunar day, there'll be power. And yeah, but the staying there longer on the moon is a problem because of the massive temperature swings. It's from 120 degrees in the sunlight to minus 173 at lunar night. So you don't have those swings if you're in lava tubes. So yeah, definitely there's problems with lava tubes. There's some technical problems for sure, but there's problems on the surface as well. So I'll guess we'll see. I mean, it could be a combination of both. You have surface elements and you have elements within the lava tubes as well. So we'll see what happens. And that is the lava tubes video. And finally, I did space news, which I released yesterday. So I just covered basically what's been happening recently. So you have the, if we go through these, we have this is the Eris-1 rocket from Gilmour Space, an Australian space company. And they are launching soon. They actually had a launch license December of last year, but then they need permits and so on. And they got everything now. There was a NOTAM. They were going to try to launch last week, the weekend, but they had a problem with the payload. The payload fairing jettisoned while it was on the ground. Some kind of electrical fault on the rocket, so they're going to need to replace the fairing and find out why it came off. So there's probably going to be a delay of a couple of weeks, and then they could try again. So it's the very first time, so there's going to be problems. So hopefully they solve the problem. This is Axiom 4, so Axiom Space. They're building a commercial space station that will replace ISS. They also do private astronaut missions. So they send private astronauts to the ISS for about a week or so. They do scientific experiments and also tourists. These are all from space agencies though. So we've got this guy on the left, Poland. So he's actually funded by ESA. This is Peggy Whitson, who's the commander, former NASA astronaut, and then you've got an Indian pilot here, Shukla, I think, and this guy is Hungarian. I'm not even going to try to pronounce his name, but he's from Hungary, funded by the Hungarian Space Agency, and these guys are doing like 60 experiments. They're very, very busy. The most number of experiments on an Axiom mission. So, yeah, Axiom 4. Next year, I think there's going to be at least 2 private astronaut missions, but I believe Vast Space also wants to do a private astronaut mission, so they may have to split with Axiom. Axiom gets one mission, Vast Space gets another. So, yep. So that is Axiom Space, which has been delayed until 8th of June, I believe. And then if I bring up this here, yes. So this is Rocket Lab's new bigger rocket called Neutron. It can lift 13 tons into low Earth orbit. It's fully reusable. The first stage comes down, but the second stage is attached to the first stage, and throughout the whole flight it stays attached. The top bit just opens, the payload comes out, and then the top bit closes, and it comes back to the landing pad. There you go. So it opens, the satellite's deployed, and then it can close and come back. So this is a new concept. SpaceX doesn't do this. They jettison the fairings and recover them afterwards. With Neutron, the fairings stay attached to the first stage or the interstage all the time. So it's a very interesting concept, and that is due to launch summer 2025, or at least the second half of 2025. So everything's going well. The first stage has been qualified. The second stage has been qualified. The launch pad is going to be activated in a couple of weeks. So soon there'll be a real competitor to Falcon 9 and Rocket Lab. They're the second company, the second launch provider after SpaceX. They've launched over 60 missions. They launched, I think, a few days ago. 60 successful missions. Their success rate, I believe, is 94%. So very, very high success rate. But they're not competing with SpaceX because the Electron vehicle only launches very small payloads. I think 600 kilos for $7.5 million. So I don't know what they're charging. I think it's something like is it something like $50 million? No, I think for medium launch vehicle, it's probably like $50–55 million, something similar to Falcon 9, but fully reusable and a real competitor, I think, to SpaceX for the first time. There's not been a real competitor until now, so we'll see how that goes. And yes, this is Varda Space. If the video plays, let's see whether it plays. Oh, that's not the video one. This is the video one. Oh, so yeah, this is just an image. Yeah. So this is Varda Space, and the third mission has landed. So this is the second mission to land in a few months, and I'll bring myself up here. So they're doing this quite routinely now. This is 3 out of 4 capsules. They have basically the satellite bus comes from Rocket Lab, and this is a capsule that gets released. Inside are pharmaceuticals that have been manufactured. Various companies want to manufacture pharmaceuticals in microgravity. The purer, the better. So this capsule can manufacture them in orbit and then come back, and you then recover the pharmaceuticals. So that's the business plan, and this is the third one. There's one more using the Rocket Lab satellite bus, and then after that, either they're going to build their own satellite bus, or they are going to continue buying more from Rocket Lab. So we'll see what happens with that. Yeah. So that is the space news this week. And yes, what else is happening that I didn't really cover? There's a few other news items. One is SpaceForge, which is a UK company that is also manufacturing space, but I think they're more interested in manufacturing materials like ultra pure space alloys and so on, stuff for defense, maybe silicon, ultra pure silicon. So not so much pharmaceuticals. So they got in their funding round, they got $30 million, or 22 million pounds. That's about $30 million. And that is apparently the largest ever for a UK space tech company at this stage. So yeah, they've got I've done a video on them if you want to know the details. But yeah, they're basically doing something similar to what Varda Space is, but they're focusing more on alloys, I think, and metals and so on in space. And the other company is Starcatcher. I've done a video on Starcatcher as well, but they've recently been testing beaming solar power on the ground. So it's a ground demonstration, beaming power from one system to another. So basically this is concentrated solar energy over 100 meters. And their business plan is to basically beam power from one satellite to another. So they have a client satellite, you basically pay for this service, and they will beam power to you, because if you're in orbit, you don't see the sun continuously. Sometimes you're in the Earth's shadow, so you get no power. So you have to use batteries and so on. So the idea is that they'll just beam power to you continuously. You can have power 24/7, and you can have more power than normal. So you got more power for your whatever your payload is, your sensors, your imaging equipment, whatever. So you can use your systems 24/7, which you can't at the moment. So that's Starcatcher, that's their business plan, and they're testing the system on the ground, and then hopefully they'll have a space demo. But yeah, I've done videos on both of these companies if you want the details. So that's SpaceForge and Starcatcher. In terms of what I'm doing next week, I don't know. I've got a few ideas on things I want to cover. I want to do some more stuff on the moon. There's some other proposals and plans and projects that I'm interested in covering. A bit like the Lockheed Martin one. There's some other concepts out there and proposals. And yeah, I'll just cover, launch providers and satellite companies and whatever else I can see. But yeah, I've not decided yet what I'm doing next week. But so thanks for watching the live stream. I do this every time at the same, Saturday evening, Sunday morning, whatever. And yeah, I just basically go through the comments on the videos, talk about the videos, and answer chat messages. And yeah, thank you for tuning in, and I'll see you next week.